So we're going to take a look at turning points, and then we're going to have a look at the second derivative. So the first thing we do is just be very quick. We want to find q if this function here, which see has a q in it there, which is an unknown, if this function has a turning point when x is 1. Now, just to remind ourselves, a function has a turning point if and only if dy dx is equal to 0. Alright, so if you remember, the turning point is the max or the min. So we said if the slope of the tangent is 0, you're either at a turning point like that, where it's a max, or a turning point like this, where it's a min. Alright, so what we do is we find dy dx, which in this case we'll be calling f of f dash x. So you differentiate 4x squared and you get 8x. Now q is just a number, it's a constant. So minus 3q is just a number, so minus 3qx just differentiates to give us minus 3q. Okay, and that's equal to 0 if we've got a turning point. Now we know that when x is 1 we have a turning point, so therefore if x is 1 we get 8 times 1 minus 3q equals 0. So if we want to find q, I guess we'll say 8 equals 3q, divide by 3 to get 8 over 3 equals q. That's the first bit of the question. Alright, so that's the value of q, which means that this function has a turning point at 1. The second bit says, is it a max or a min? Now, if you remember, we said that if dy dx equals 0, so if we do have a turning point, then if the second derivative is positive, it means we have a min. If the second derivative is negative, it means we have a max. Alright, and we'll explain in a second where they come from. So just to do this, let's just remind ourselves what dy dx is. It's 8x minus 3q. So the second derivative means we differentiate this again, differentiate 8x and we get 8. Differentiate minus 3q and you get 0, because q is just a number. If you like, we can write this is 8x minus 3 times 8 over 3, which is 8x minus 8. Alright, so differentiate that, you just get 8, which is bigger than 0, and that means we have a min at x equals 1. Okay, so now let's take a look at why this actually works. Okay, so why is it that we look to the second derivative to give us the min? And to see this, we look back to the first derivative. So if you take a kind of a typical cubic like that, and if we look at the derivative, so let's say we look at the derivative at this point. So here we have dy dx equals 1 maybe. Up here you've got dy dx equals 0, and here you might have dy dx equals 2/3. Alright. What I'm doing, I'm trying to draw the tangents at any given point. So what you're trying to do is you're trying to draw the line that touches the curve at that point without going through the curve. So these here we've got dy dx is positive. Up on the top it's 0. Right? Down on the bottom here it's 0 again. In the middle here it's negative. So if you think about these kind of tangents here, so here dy dx is a minus. Here it's a plus, here it's a minus. Here it's 0, and here again the thing rises off again, so dy dx is a plus again. Now, the question is, what information is this giving us? Well, what dy dx is telling us is, as we move along, how is my height changing? So if dy dx is a plus, it means I'm going up. If dy dx is a minus, it means I'm going down. If dy dx is a plus, it means I'm going up again. If dy dx is 0, it means I'm going straight across. Okay, so let's just, there's where dy dx is 0. There's where dy dx is 0 again. So here you've got dy dx plus. Here you've got it a minus, here you've got it a plus. Over here I'm going up, in the middle I'm going down, and over here I'm going up again. Alright, and so dy dx tells us whether I'm going up or I'm going down, and if you think back to the coordinate geometry, going up or going down means what's happening, the y value. So here the y values are increasing, here the y values are decreasing, and here the y values are increasing again. Alright, so that's what dy dx is telling me. It's telling me, are the y values going up, are they increasing, or are the y values coming down? So dy dx tells me how the y is changing. In the same way, if you differentiate, so I get dy dx by differentiating y. If I differentiate dy dx, I get d2y dx squared. And this tells me how dy dx is changing. Alright, so the first one of these, dy dx, tells how y is changing. That tells me why I need to look at when is dy dx 0. Okay. The second one is going to tell me how I know things are max or min, and it's also going to fill in that blank that we left as to what happens when d2y dx squared is 0. Alright, so let's have a look at dy dx. As we move across from left to right here, I've got quite a big positive slope down here. Right, so dy dx is plus, and it's a pretty big plus. Now, the slopes are getting shallower and shallower as I move along. Right, so dy dx is decreasing as I move along here. Alright, it's getting smaller. It turns negative here. And then there's a point, right? So it's going down, 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 down. And then there's a point where it stops going down and it starts to curl back up. So that point there is the critical point when we're looking at d2y dx squared. Okay, so up until that point, dy dx is decreasing. At that point, it kind of stops decreasing, and as we move away from that point, now they're still negative. The dy dx are negative, but they're starting to get bigger, right? So they get bigger towards 0, and then they get bigger positively. So here we've got dy dx actually increasing. So what that means is that over here, if you think back to what we had over here, we said, right, if y is increasing, dy dx is a plus. If y is decreasing, dy dx, the derivative is a minus. Right, so if dy dx is decreasing, the derivative is going to be a minus. If dy dx is increasing, the derivative is going to be a plus. Now, anytime you have dy dx decreasing and you have a turning point there, because it's decreasing, it's going to be curving this way, so your turning point has to be a max. So that's why if dy dx is 0, so if it's coming straight across, and the second derivative is minus, I have a max. On the other hand, if you want to have a min, you've got to come down to a min and then back up. And what that means is that your slopes, your tangents, have to be increasing as you move along. So in this case, if I've got d2y dx squared bigger than 0, so a plus, I'm going to have myself a min. And the final point is what happens when dy dx is equal to 0? Well, at that point, it goes from curving this way to curving this way. And that there is called a point. We haven't made it yet. It's called a point of inflection. And that is where d2y dx squared is equal to 0. And that's the point where it goes from curving like this to curving like this. And on occasion, last sheet, on occasion you can actually have a curve. So let's have a look at a very simple curve. The curve y equals x cubed. Right, so let's differentiate that. Let's look at dy dx. So dy dx tells us dy dx is 3x squared. Right, now that's equal to 0 at the turning point. In other words, at the max and at the min. If you want this to be 0, the only way to have 3x squared 0 is that x is equal to 0. So we're looking at the point 0, 0. So that tells us that the point 0, 0 is the turning point. Now to see whether it's a max or a min, we'd have a look at the second derivative. And you kind of hopefully see from the picture there's going to be a bit of a problem. Because this point is not a max. Because it's not if you look at any little kind of circle around here, it's not bigger than everything. Right? It's bigger than the bits on the left, but it's smaller than any of the bits on the right. So it's not a max because it's smaller than these bits, but it's not a min either because it's bigger than these bits. Right? So maybe you can kind of guess what it's going to be. So d2y, let's look at the second derivative, and you get 6x. Now, at the point we're interested in, the second derivative is 6 times 0, which is 0. So that means it's not a max and it's not a min, it's a point of inflection. So 0, 0. Sometimes spelled like that, sometimes spelled the other way. I can never remember what way I meant to spell it. Anyway, the point is that in here, d2y dx squared is equal to 0, and that means this is the point where it goes from curving that way to curving that way. So even though the first derivative is 0, that still doesn't mean you have a max or a min. So it's like saying, if there's a robber in the house, my dog will bark. Okay, but just because my dog barks doesn't mean there's a robber in the house. So if I have a turning point, then dy dx will be equal to 0. But just because dy dx equals 0 doesn't mean I have a turning point. There's a third possibility. I may have a turning point, I may have a max, I may have a min, or I may have a point of inflection. So you check the second derivative and you see what kind of a point you have. And in this case, I don't have a max or a min, I have a point of inflection. So if you think about it here, dy dx is bigger than 0 the whole time because the function is always increasing. Right? So dy dx is always bigger than 0. Okay, and you can see that if you move along, the function never gets smaller. So the derivative, if you look at all the tangents, they're all going up. This one, well, let's say bigger than or equal to. This one is equal to, and all the rest of them are bigger than 0. Okay, but what's happening, that derivative, is that's a very steep curve going up, right? And it gets smaller and smaller and smaller. So dy dx is decreasing over here. So in this part of the graph, the second derivative will be negative. Okay, over in this part of the graph, it starts off at 0 and then it starts getting steeper and steeper and steeper, which means dy dx is increasing. And what this means is that d2y dx squared in this part of the graph is bigger than 0. And then in the middle, you have the point where it switches from being curved like this to being curved like this. And that's what the second derivative tells us.